Hello and good morning friends, welcome to the CEC EduSet live lecture. Dear friends, we are again with you and we have brought for you a very new and a fresh topic. This very topic is data warehouse. What is data warehouse? We are going to discuss and we are going to know more about this topic, and today we have again with us Dr. U.S. Pandey. He is Associate Professor in School of Open Learning. Hello sir, welcome to the EduSet lecture, and I would like you to explain us in detail what is data warehouse.
Okay. Let's see data warehouse. In many organizations, the store of all our entities, concepts, metadata and historical informations for doing data validation, complex mining, analysis, predictions and this is the data warehouse. A data warehouse in a single integrated store of data which provides the infrastructural basis for the information application in the enterprises. Where it is used? It is used for evaluating future strategy. It needs a successful technician, flexible, team player, good balance of business and technical understanding. Data warehouse advantages: access to the information, data inconsistency, decrease computing cost, productivity increase, increase company profits. Disadvantages are also there. Data must be cleaned, loaded and extracted. It's around 80% of the overall process. User variability, proper training should be given to the persons who are using all this. Difficult to maintain, incongruence among systems. Data warehouse: in order for data to be effective, data warehousing must be consistent, well integrated, well defined, well stamped, and data warehouse environment, the data store, data mart and the metadata. An operational data store, ODS, stores data for a specific applications. It needs the data warehouse of a stream of desired raw data. Is most common component of DW, data warehousing environment. Data store is generally subject oriented, volatile, current commonly focused on customers, products, orders, policies, claims, etc. Data warehouse and data store. See, the characteristics how it is built. The operational data store, one application or the subject area at a time. What is data warehouse is typically multiple subject areas at a time. Area of support, day-to-day business operations. The data warehouse is the decision support for the managerial activities. Currency of data, the operational data store is up to minute real time, and data warehouse is typically represents a static point in time. The typical units for the analysis is small, manageable transactions level unit. In the data warehouse, it's large, unpredictable, variable units. Design focus, high performance, limited flexibility. In the case of data warehouse, is high flexible, high performance. The data store could not do. Its day-to-day function is to store the data for a single specific set of operational functions. Its function is to feed the data warehouse data for the purpose of analysis. A data warehouse is a collection of integrated subjects oriented databases designed to support a decision support system, that is DSS. Each unit of data is non-volatile and relevant to some moment in time. An operational data store, ODS, store data for a specific application. It feeds the data warehouse a stream of desired raw data. A data mart is a low-cost, scaled-down version of a data warehouse, usually designed to support a small group of users rather than the entire firm. The metadata is information that is kept about the warehouse. What is this warehouse? the subject oriented, data integrated, time variant, non-volatile. The characteristics of a data warehouse: subject oriented, data are organized based on how the user refer to them. Integrated, all inconsistencies regarding naming, convention and the value representation are removed. Non-volatile, data are stored in read-only format and do not change over time. Time variant, data are not current but normally time series. Summarized, operational data are mapped into a decision usable format. Large volume, time series data sets are normally quite large. Not normalized, data warehouse data can be and often are redundant. Metadata, data about data are stored. The data source, data come from internal and external unintegrated operational systems. A data warehouse is subject oriented. Here you can see through this map, series and marketing planning and all different kind of application areas in the finance, inventory, human resource, assets taking, and how it is subject oriented. The vendors, markets, employees, salary history, consumers, products and all is linked. Subject orientation, application environment, design activities must be equally focused on both processes and database design. Data warehouse environment, data warehouse word is primarily wired of processes, design and tend to focus exclusively on the issue of data modeling and database design. Data integrated, integration, consistency, naming, conventions and measurement, attributors, accuracy and common aggregation. Establishment of a common unit of a measure for all synonymous data elements from this similar database. The data must be stored in the data warehouse in an integrated, globally acceptable manner. Here you can see the data integrated things, transformation and cleaning, application, gendered data names and all. Here how the data warehouse is going to be the gender, data and balance and all. Time variant, it is a very important factor of that. In an operational application system, the expectation is that all data within the database are accurate as of the moment of access. In the data warehouse, data are simply assumed to be accurate as of some moment in the time and not necessarily right now. One of the places where data warehouse data display time variance is in the structure of record key. Every primary key contained within the data warehouse must contain either implicitly or explicitly an element of time, day, week, month, etc. Every piece of data contained within the warehouse must be associated with a particular point in time if any useful analysis is to be conducted within it. Another aspect of time variance in data warehouse data is that once recorded, data within the warehouse cannot be updated or changed. Non-volatile, typical activities such as deleters, inserts and changes that are performed in an operational application environment are completely non-existent in a data warehouse environment. Only two data operations are overperformed in the data warehouse: data loading and data access. Non-volatility, application, the design issues must focus on data integrity and update anomalies. Complex processes must be coded to ensure that the data update processes allow for high integrity of the final product. What data warehouse will do? Such issues are no concern to in a data warehouse environment because data update is never performed in data warehouse. In application, data is placed in normalized form to ensure a minimal redundancy. That total that could be calculated would never be stored. In data warehouse, designers find it's useful to store many of the such calculations or summarizations. The technology necessary to support issues of transaction and data recovery, rollback and detection and the remedy of deadlock are quite complex. In data warehouse, relatively simplicity in technology. Data warehouse versus heterogeneous database management system. Traditionally, heterogeneous database integration, a query-driven approach, build wrappers, mediators on the top of heterogeneous databases. When a query is posted on a client site, a meta dictionary is used to translate the query into the queries appropriate for the individual's heterogeneous site involves, and the results are integrated into a global answer kit. Complex information filtering compete the resources. Data warehouse, update driven, high performance. Information from heterogeneous sources is integrated in advance and stored in a warehouse for direct query and analysis. Data warehouse versus operational DBMS, OLTP, that is online transaction processing. Major task of traditional data relational database DBMS. Day-to-day operations, purchasing, inventory, banking, manufacturing, payroll, registration, accounting, etc. OLAP, online analytical processing. Major task of data warehouse system, data analysis and decision making. Distinct feature, OLTP versus OLAP. User and system oriented, customer versus market, data content, current, detailed versus historical, consolidated, database design, ER plus application versus star plus subject, view, current, locus versus eventually integrated, access patterns, update versus read only but complex queries. OLTP versus OLAP. Users, clerk and professionals, they use the OLTP, and OLAP is going to be the knowledge and workers, function, day-to-day operation, decision support, database design, application oriented, subject oriented, data, current, up to date, detailed, flat relational, isolated. In the case of OLAP, it's historical, summarized, multi-dimensional, integrated and consolidated. Uses, repetitive in nature in the case of OLTP, in OLAP it is ad hoc. Access, read, write, index, hash or primary key. Loss of scan, unit of work, sort, simple transactions, complex query, record access, tens, millions, users, thousands, in the case of OLAP, hundreds, DB size 100 MB to GB, 100 GB to terabyte, metric, transaction through output, query thought and response. Why separate data warehouse? High performance for both system, DBMS, tuned for OLTP, access method, indexing, concurrency control, recovery. Warehouse, tuned for OLAP, complex OLAP queries, multi-dimensional view consolidation. Different functions and different data. Missing data. Decision support requires historical data which operational DB do not typically maintain. Data consolidation, DS requires consolidation, aggregation, summarization of data from heterogeneous sources. Data quality, different sources typically use inconsistent data representation, codes and formats which have to be reconciled. There are more than systems which perform OLAP analysis directly on relational databases. The data warehouse architecture. The architecture consists of the various interconnected elements, operational and external database layer, the source data for data warehouse, information access layer, the tools to the end user access to extract and analyze the data, data access layer, the interface between the operational and information access layers, metadata layer, the data directory or the repository of the metadata information. Components of the data warehouse architecture. You can see here the application messaging layer, information access layer, data access layer, data warehouse, data staging layer, data access layer and operational data store. Data dictionary functions, process management and data dictionary connected. The data warehouse architecture's additional layers are process management layers, the scheduler or the job controller, application messaging layer, the middleware that transport the information around the form, physical data warehouse layer where the actual data used in the DSS are located. Data staging layer, all of the processes necessary to select, edit, summarize and load warehouse data from the operational and external databases. Data warehouse typology. The virtual data warehouse, the end users have direct access to the data stores using tools enabled at the data access layer. The central data warehouse, a single physical database contains all of the data for a specific functional area. The distributed data warehouse, the components are distributed across several physical databases. The metadata, which is a very important things about the data warehouse, the name suggests some high level technological concept, but it really is fairly simple. Metadata is data about data. With the emergence of the data warehouse as a decision support structure, the metadata are considered as much a resource as the business data they describe. Metadata are abstractions. They are high level data that provide concise descriptions of the low level data. General metadata issues. General metadata issues associated with the data warehouse use, what tables, attributes and the key does the data warehouse contain, where did each set of data came from, what transformations were applied with cleansing, how have the metadata changed over time, how often do the data get reloaded, are there so many data elements that you need to be careful what you ask for. Components of metadata, transformation maps, records that show what transformatics were applied, extraction and relationship history, records that show what data was analyzed, algorithms for summarization, methods available for aggregating and summarizing, data ownership, records that show origin, patterns of access, records that show what data are accessed and how often. Typical mapping metadata. Transformation mapping records include identification of original source, attribute conversions, physical characteristics conversion, encoding references, table converges, naming changes, key changes, value of default attributes, logic to choose from multiple sources, algorithmic changes. Problems of the data warehouse: high demand for resources, data ownership, high maintenance, long duration project, complexity of integration. Typical architecture of a data warehouse, which you can see it, that the warehouse manager is going to be there, who is controlling each and everything. Architecture backup facilities are going to be there, operational data resources are going to be there, operational data source is going to be there, operational data different sources are going to be there, reporting, query and application in development and EIS tools are there, OLAP and different data mining tools are also going to be there, and then see the end user access is also going to be there. Operational data sources: mainframe, first generation hierarchicals and network databases, departmental priorities, file system, for example VSAM, RMS and relational DBMSs like Informatics and Oracle, private workstations and servers, external systems such as the internet, commercially available databases are the databases associated with an organization's supplier or customers. Operational data store, that we call ODS, a repository of current and integrated operational data used for analysis, often structured and supplied with the data in the same way as the data warehouse. May act simply as a staging area for data to be moved into warehouse, often created when legacy operational systems are found to be incapable of achieving reporting requirements. Provides users with the end use of a relational database while remaining distinct from the decision support functions of the data warehouse. Load manager performs all the operations associated with the extractions of the loading of data into warehouse. Size and complexity will vary between data warehouse and may be constructed using a combination of a vendor data loading tools and customer built programs. Warehouse manager performs all the operations associated with the management of the data in the warehouse, constructed using vendor data management tools and custom built programs. Warehouse manager operations and performs include analysis of data to ensure consistency, transformation and merging of the source data from temporary storage into data warehouse tables, creation of indexes and views on the base table, generation of denormalizations if necessary, generation of aggregations if necessary, backing up and achieving data. Warehouse managers in some cases also generates query profiles to determine which index and aggregations are appropriate. A query profile can be generated for end user, group of users, or the data warehouse and is based on information that describe the characteristics of the queries such as the frequency, target tables and size of the result set. Query manager performs all the operations associated with the management of the user's queries, typically constructed using vendor end-user side vendor access tools, data warehouse, monitoring tools, database facilities and custom built programs. Complexity determined by the facilities provided by the end-user access tools and the database. Query managers also perform the operations by its component include direct queries to the appropriate tables and scheduling the execution of queries. In some cases, the query manager also generate query profile to allow the warehouse manager to determine which indexes and aggregations are appropriate. Detailed data. Store all the detailed data in a database schema. In most cases, the detailed data is not stored online but aggregated to the next level of detail. On a regular basis, detailed data is added to the warehouse to supplement the aggregating data. Lightly and highly summarized data stores all the predefined lightly and highly aggregated data generated by the warehouse manager. Consistent as it will subject to change on an ongoing basis in order to respond to changing query profiles. The purpose of summary of information is to speed up the performance of a queries, removes requirement to continually perform summary operations such as sort or group by in answering user queries. The summary data is updated continuously as new data is loaded into the warehouse. Archives, backup data stores detailed and summarized data for the purpose of archiving and backup. May be necessary to backup online summary data in the data to kept beyond the retention period for the detailed data. The data is transformed to store archives such as magnetic tapes or optical discs or it could be a latest devices. This area of the warehouse store all the metadata, data about data as we have just discussed, definitions used by all the purpose in the warehouse. Used for variety purposes. Extraction and loading processes, metadata is used to map data source to a common view of information within the warehouse. Warehouse management process, metadata is used to automate the production of a summary tables. Query management processes, metadata is used to direct a query to the most appropriate data source. The structure of metadata will differ between each processes because the purpose is different. This means that the multiple copies of metadata describing the same data item are held within the data warehouse. Most vendor tools for copying management and end user data access use their own version of metadata. Copy management tools use metadata to understand the mapping rules to apply in order to convert the source data into a common form. End user access tools are use metadata to understand how to build a query. The management of metadata within the data warehouse is a very complex task that should not be underestimated. End user access tools. The principal purpose of data warehouse is to provide information to business users for strategic decision making. These users interact with the warehouse using end user access tools. The data warehouse must efficiently support ad hoc and routine analysis. High performance is achieved by pre-planning the requirements for joins, submissions and periodic reports by end users where possible. There are 5 main groups for access tools: data reporting and query tools, application development tools, executive information system tools, online analytical processing tools and data mining tools. Data warehouse information flows, as we have just described, that operational data source 1, operational data source and different sources inflow the informations which is connected again with the same reporting, query and application development, EIS tools, OLAP and this warehouse concepts are going to be there. The data warehouse information flows, inflow, processes associated with the extraction, cleansing and loading of the data from source system into the data warehouse. Upflow processes associated with adding value to the data in the warehouse through summarizing, packaging and distribution of the data. Downflow processes associated with archiving and backup recovery of the data in the warehouse. Outflow processes associated with making the data available to the end users. Metaflow processes associated with the management of the metadata. Data warehousing tools and technologies. Building a data warehouse is a complex task because there is no vendor that provides an end user to end set of tools. Necessitates that a data warehouse is built using multiple products from different vendors. Ensuring that these products work well together and are fully integrated in a major challenge. Extraction, cleansing and transformation tools. Task of capturing data from source systems, cleansing and transforming it, and it loading the results into a target system can be carried out either by separate products or by a single integrated solution. Integrated solutions include code generations, database data replication tool, dynamic transformation engine. Data warehouse database management system requirements. Load performance, load processing, data query management, query performance, terabyte scalability, mass user scalability, networked data warehouse, warehouse administration, integrated dimensional analysis, advanced query functionality. Data warehouse parallel database technologies aims to solve decision support problems using multiple nodes working on the same problem. Performs many databases operations simultaneously, splitting individual tasks into smaller parts so that tasks can be spread across multiple processes. Parallel DBMSs must be capable of running parallel queries, parallel data loading, table scanning and data archiving and backup. Data warehouse parallel database technologies. Two main parallel hardware architectures include symmetric multiprocessing SMP, massively parallel processing MPP. SMP, a set of tightly coupled processors that share memory and disk storage. MPP, a set of loosely coupled processors, each of which has its own memory and disk storage. Data warehouse metadata. The metadata is used for variety of purpose and management of metadata in a critical issues in archiving a fully integrated data warehouse. The major purpose of metadata is to show the pathway back where the data began to, so that the warehouse administrators know the history of any item in the warehouse. Problem is that metadata has several functions in the data warehouse: data transformation and loading, data warehouse management, query generation. Data warehouse metadata, the problem is that metadata has several functions in the data warehouse: data transformation and loading, data warehouse management, query generations. Various tools of the data warehouse generate and use their own metadata. Major challenges is to synchronize the various types of metadata. The industry organizations, the metadata consolidation and the object management group have merged to propose a single standard for metadata and modeling in data warehouse called the Common Warehouse Meta Model, CWM. Allows users to exchange metadata between different products from different vendors freely. Administration and management tools, monitoring data loading from multiple sources, data quality and integrity checks, managing and up-to-dating metadata, monitoring database performance to ensure efficient query response, time and resource utilization, auditing data warehouse uses to provide users chargeback information, administration and management tools, replicating, subsetting and distributing data, maintaining efficient data storage management, processing the data, archiving and backup the data, implementing recovery following failures, security management, typical data warehouse and data mart architecture. The way you can see it, how the warehouse manages and all the different kind of operational sources have been interconnected with all the different layers. What is data mart? A subset of data warehouse that supports the requirements of a particular department or business functions. Characteristics include focuses on only the requirements of one department or business function. Do not normally contain detailed operational data, unlike data warehouse. More easily understood and navigated. Regions for creating a data mart. To give users access to the data they need to analyze most often. To provide data in a form that matches the collective view of data by a group of users of a department or business function areas. To improve end user response time to the reduction in the volume of data to be accessed. Regions for creating a data mart. To provide appropriately structured data as dictated by the requirements of an end user access tools. Building a data mart is simpler compared with establishing a corporate data warehouse. The cost of implementing data marts is normally less than that required to establish a data warehouse. Data mart issues, data mart functionality, data mart size, data mart load performance, users access to data in multiple data marts, data mart internet or intranet access, data mart administration, data mart installation. As we have just mentioned, data mart is basically a subset of that data warehouse. So you can see the all these possibilities are going to be there. Regions for creating a data mart. The potential users of a data mart are more clearly defined and can be more easily targeted to obtain support for a data mart project rather than a corporate data warehouse project. The future of data warehouse. As the data warehouse becomes a standard part of an organization, there will be an effort to find new ways to use the data. This will likely bring with several new challenges, which include regulatory constraints may limit the ability to combine sources of disparate data. These disparate sources are likely to contain unstructured data which is hard to store. The internet access, it's possible to access data from virtually anywhere. Of course, this just increases the disparity. Data can be used to quantify the volume impact of the vehicle across the marketing matrix, account for decay and saturation factors in the determination of investment choices and returns, execute what if simulations and the prices of the promotional scenarios before a proposed action is taken, provide a continuous planning, measurement, analysis and the optimization cycle supported by a software structure. Deliver robust data feeds into the system, supportedly supply chain, scale, sales and the financials reporting and individuals. And that's things about which we have talked about, that the data warehouse. We have mentioned only limited use of that one, but basically data warehouse, the maximum thing can be utilized in all part of the system, especially in the government department.
Definitely, sir, you have given a deep insight into this very topic. But if we talk about data warehouse in the common terms, can we say that we can use a term storing with it?
You are absolutely right. As I mentioned, it is just like a storing, only in a big way you can call it. The term which we have used, data warehouse, little bit in that way, that you can store a large amount of data which can be used for any specific purpose. You can take a just example, if a government is planning something, just take a recently case of price rising. You can understand that the price rising, if a government has a better planning, through the data warehouse, they do have a lot of information exactly where the things are stored, in what form, what is the, in what manner, exact locations and everything. What I mean to say that pricing can be controlled through the proper organizational things and getting the proper information through the data warehouse. Second thing, at the same way they can store the information in a proper way. You may be knowing very well that just now even the government HRD ministry is just planning to making all the kind of your certificates, documents, each and everything in a repository form. So they are just trying to create a kind of big data warehouse concept where all your documents will be stored. Nobody from any part of the India is required to store their document separately. Everything will be in a place only with, as we have just given some terminologies like load managers are going to be there, warehouse managers are going to be there, query managers are there. With the help of all these kind of things, you can access your things easily. That is the objectively in a common
this means that the things which are we used to store, or we used to store in the files or the papers, now could be stored on our computers.
That is only one aspect I am talking. I mean, later on you can use for any purpose. Now there is a second scenario of that. The same data warehouse can be used by the government for validating your things are also. Take example, suppose I am just taking, although the main uses of warehouses and all is still going to be in the area of business and all, but government can use all these things in a different areas and they can get it verified all, because here the things are stored in a very structured way. The data which you are providing by different technologies, as we have just mentioned, that you can, things are there in a very structured way, and government or anybody can use things in a very proper manner.
So, are there any chances of error? Because if you talk about storing data, means you are having a very huge file altogether. So, are there any chances of error that if we don't store in a proper manner, in future we are going to cater some problem?
Definitely, you are very right. The question is very important and very rightly, as in now here very important thing, as you just storing the data. The source of data, from where you are getting the information, all these things are very important factor, plus the technology which you are using, whether what kind of things are going to be there. The first important thing is that the source of data, from where you are getting the data, the validation, the authenticity and all are the very important factors. So naturally these things are going to be then important issues, and which is being addressed time by time naturally for all the aspects. There are different controls are going to be there for having the correct data, as we have discussed just now, because the validation of data, the authenticity of data and how these things are being processed, that is also important. And in between we have created the metadata concept also. You must be knowing about the nature of the data, how much, for example, at the moment you require the latest data and somebody has provided you the data of the 2 year back. So that is not no of use of your maybe. So those things are going to be the important factor. How the data is stored, from what is the source of data, what is the planning to produce the things in a manner. Each and every points need to be addressed properly.
This could be, metadata could be very successful in the digital libraries where there are huge number of books and it is impossible for a librarian to track and store in files or the registers. With the help of metadata, we can access any book, any of the libraries.
That is the objective, as you have mentioned very rightly. As I mentioned, this warehouse concept is very important and it can be used definitely in any area of the area. You have very rightly mentioned library could be one of the biggest area where things can be used very properly, and using the different technology. A person, if you are, for example, if you are searching for a particular article within a specific library, maybe you are knowing each and everything with the specific. Sometimes you don't know about the author's name, sometimes you don't know about the book name, sometimes you don't know about the journal's name, sometimes you don't know when the article was published, date, time, another thing. Many times, many things, there are many ways to access the information from that library and all these. So this concept can be used there also, and very rightly we can do in that way.
With the help of the keywords, it is easier to store or
Definitely.
to
See,
find.
there are just like a database structure already, things are well defined. Here also they are used in the same manner also. Little bit different technologies are being used. Maybe the structure is little bit complex because the storing in the data warehouse is little bit more complex than the other things. Maybe it is little bit costly also, but there are lower version, as we have just discussed about your data mart also. So there are facilities which can be used easily. Only important thing is that cost may be little, because the infrastructure facility, the software and all these things requirement may be little bit higher than the usual thing.
If we talk about the organizations which have been running or which are running since a very long time, people may come, people may go according to the tenure in the organization. But if with the help of the metadata data, or we talk about the warehousing, it becomes possible for the future people to come and see what the people in the past have done.
The basic objective, very right questions you have asked, very rightly, as I just mentioned, the basic objective of the warehouse is for taking strategic decisions. When you are having a big planning for our organizational key persons, they have all the information up to date. I mean, take an example, if you have stored data from last 20 years, so you can easily think that the total data you have stored, you will be able to understand, analyze the things properly, what kind of improvement you have done, what is the nature of change of data, and all these things are going to be stored. So huge examples are going to be there, and especially as I mentioned, especially in the big organizations where these data is stored, you can get lot of information just by analyzing the data.
By analyzing the data. So when we are talking about of a huge span, for example, if a person is accessing the data of more than past 30 or 50 years, is there any maintenance kind of thing required while taking care of this?
Very right. Again I'm pointing out that the basic objective of the warehouse is to maintain the data in a proper manner. That is the very important factor, and these are the, as I mentioned, the three basic important things: the source of data, how you are getting it, how you are storing it properly in that setup is more important. That for that purpose the security systems are going to be there, how this secures. And another thing is, nobody can change the data once the data is stored. Technically there is no possibility to change that particular, because these are informations which are stored in that proper manner. Nobody can change technically. So those informations, data, and what is the structure to be used for the storing of data is going to be again important factor. The way, so that later on, suppose some information which you are accessing at the moment, some information which you are going to take after 20 year or 30 year, like that. So those informations are in which order, how the things are going change, format and all. Now you can see every different kind of files are changing from one format to another format, software to software, things are varying. So you have to keep all those things in mind when these kind of structures are going to be maintained, and this concept is going to be there.
For this chronology kind of thing required to be maintained, for example, a thing was made in year 1990 and then in 2000 somebody is accessing that. So in that order, in that manner, a chronology is required to be maintained.
There is a system, there is already system, already you are knowing when you are just transforming your life. For example, earlier people used to just run by their own feet. Then they have started using cycling. Then they have started using on motorcycles. So the thing is that just changing step, and now they are using cars, sometimes buses, you have using now metros and all. So what is happening is the structural changes are coming into the thing. The same thing is happening, and not only this, it's changes in the nature of the data also. the source of data, authenticity. For example, you are collecting lot of information from the internet. How much the authenticity of that particular data is going to be there, that is very important. How, when you are collecting the data from the raw source, that the importance, the authenticity and the validation, each and everything, that person who is collecting data, whether he is an authorized person or you are getting the data of the different form. So those kind of correctness and all these things are playing a very important role to maintain the things in a data warehouse. So that is why we say the quality is also one of the important factor. Quality of data, I mean quality of data, because only when you are going to get a good quality of data means the proper authentication, validation and all, only then you can do the proper analysis, and based on that you can take any strategic decision.
If we talk about metadata, there must be some softwares regarding this, and special people or special training is required for this, for operation?
Exactly, very much right in that way, because here it's a big activity is going to be there, and metadata concept, and as I mentioned, there are many other things are going to be there. Different, like there is a load managers are going to be there, there are warehouse manager is going to be there, the query managers are going to be there, data mart concept we have talked about. So lot of functionality are going to be there, and everyone is having a different kind of concepts are going. So itself is a big task into the warehouse system itself. So you required expertise in that particular area. It's not that anybody can handle all those things. You need the expertization of the database systems. You must know about the software, that too in deep. Not peripheral requirement is going to be there, that how the data is going to be stored properly, as well as how the things are being loaded properly, how the queries are going to be generated, how the analyzing things are going to be generated. All these things are required the expertization in that particular area.
So only then access will become easier, and what the person is trying to search,
you are absolutely right. In that way, only then the end user, the meaning is that a common person will get the facility, when, because only then it becomes user friendly to you. For example, you have some kind of query with that particular data warehouse and all this. So naturally, you have to just post a query. The query manager will go into that detail, and he will try to provide you all the information as required by you in that way.
If we talk about the sharing, is there any privacy criteria with the sharing? Can be
as you mentioned, again I am putting, these security issues are very important, and still a lot of things need to be done in this particular area, although they have a different security labels are already going to be there, but still these areas need to be addressed in more detail. Many security steps are already being there, because there are the concept was from the software point of view, as well as the hardware kind of restrictions are also going to be there to control many things. For like you can call it theft of data, copying of data, so many other things are going to be there. Very many things are being taken care, but still a lot of things need to be done in the area of security of that particular things.
Because if somebody in some organization have certain data, one can log that data that nobody can, other than that person who is operating, cannot access other than that person.
Technically, as we have discussed earlier, also I have told you, there is a system of authenticity. But only thing is that the only proper person or the administrator can log in into the system. For example, at the very important, from the security point of view, the loading of information, the loading of important data. Now, loading of data itself is a very secured system, because for example, when you are going to the load the data, whether you are getting the authentic data or not, that is very important. What is the source of data? So from that point of time, maintaining all the data as well as having all these things is very important in this particular area.
So what do you think that any big or small organization can have a metadata kind of thing?
See, usually it is not very difficult to do all this kind of, but as I mentioned, this cost is a very important factor. For establishing a data warehouse in a big way, you required a huge amount, and big organizations are already there doing in this particular field. Although some of the big organizations or computer industries are also providing the facility to you store each and everything properly, because a huge space is require infrastructure is going to be required, cost is requiring. Plus the very important thing, as you was pointing number of times, security is very important. So all those kind of things are going, and as I mentioned, slowly things are taking place, because every organization now in the digital age required this kind of concept.
is this warehousing concept is included in some curriculum or some training programs? where students can learn?
Almost all the things where computer science is being taught, this data warehouse, which is directly linked with the things which we are going to talk later on, data mining, which is the very important factor related to this, is being taught in every computer courses almost, especially in the master level or some at BTech and MTech level, and they are talking about the technology also, the things which are happening, latest things were happening about also. People are aware about these common terms. Warehouse is a very common term, only we have added data in that way. So now technologically things, it's very common and very useful, which is going to be things to be need to be more developed in a more way. That is the things that are going to be there.
Definitely, sir. Thank you so very much. You have given such a deep insight into this very topic, and all the students who might be watching us and all those viewers who might be watching us may be getting benefit and they want to learn more about it. Thank you, sir. Thank you so very much for being with us.